Hello everyone, welcome to the lecture 3 on oscillator by Yashoda. In the last lecture we discussed about the condition of the oscillators that is called as Barkhausen criterion. In that we have the two conditions. The first one is the total phase shift around a loop is equal to 0 degree or it is equals to 360 degree, and the feedback must be positive. The second one is the magnitude of the product of open loop gain A and the feedback factor beta is equals to 1 or is unity. So if these two conditions are satisfied, then the circuit will produce a sustained oscillations of constant frequency. So in the last also we discussed the positive feedback and the negative feedback and the types of oscillators. The first one is sinusoidal and non-sinusoidal, and sinusoidal further classified as LC and RC. So here we will discuss today's lecture the RC oscillators, that is the combination of the resistor and the capacitor. So for example, the phase shift oscillators. Okay, right. So in the phase shift oscillators, and it is also called as RC phase shift oscillator. RC phase shift network is a simple resistor capacitor network that can be used to give a desired phase shift to a signal. The circuit diagram of phase shift oscillator using NPN transistor. So the phase shift oscillator is involved the transistor which is in the which type means the NPN transistor, and it is in CE mode configuration. And this consists the phase shift oscillator network circuit is consist the resistors RE and RL that provides a proper DC bias for the transistor amplifier. So see here, this is the network of the RC phase shift oscillator. So here is the transistor, you can call it as Q, and RL, here is the RL, and here is the RE. R provides a proper DC bias for the transistor of the amplifier. Okay, and here is the positive V is nothing but this is connected to the positive of the VCC, and here three identical RC combinations network is there, that is nothing but the feedback network of this circuit. So here the this consists the three combination means the identical combination of R and C are used for phase shift and the feedback network, and this consists three identical RC sections. So that those three RC sections provides a phase shift of 60 degree. So here the CR, CR, CR. So these are the three identical RC sections. Each sections produces the 60 degree phase shift. So the first RC produces 60 degree, and then second one is produces a 60 degree. The third one is also. So thereby the combination of these identical three RC sections provides the 180 degree phase shift to the network. So this RC section, three identical RC sections is nothing but the feedback network of the oscillator, and here the transistor is provides again itself a 180 degree phase shift to the network. So then the total phase shift around the loop is becomes the 360 degree, or you can call you can write it as a 0 degree. So then the first condition will be satisfied, the net phase shift of the feedback network becomes 180 degree, and the transistor gives the 180 degree. Then the total phase shift becomes the 360 degree. The first condition will be satisfied, and this RC section feedback network is gives the positive feedback because it increases the gain of the amplifier. Okay, and here this is about the explanation of the diagram and how it works means here. So let us consider the positive VCC will be connected to the positive VCC means the battery power supply. So when switch on the power supply here, the when DC power supply VCC is switched on, the circuit produces the minor variations in the transistor of the amplifier. So this variation in the base current is amplified in the collector circuit and then feedback to the RC network. Means in the transistor when switch on the power supply, the using the RL, it comes to the current will comes to the transistor by the minor variation. So that after that this variation is gives the to amplify the signals. After that amplifying the signals, it gives the output. So that output is fed back through the feedback network. Here the feedback network will be RC sections, 3 RC sections. Okay, so by the feedback network, the output signals are fed back through the feedback network and again it goes to the transistor. So here when it is the network produces 180 degree phase shift between its input and output voltage. So then the another additional 180 degrees phase shift is provided by the transistor itself. So then the total becomes the 360 degree. Then the circuit acts as an oscillator. Okay, and then the oscillator produces sine wave output voltage continuously because when here amplify means it magnifies the weak signals. So if we after feedback after the output signals are fed back through the feedback network, if it is strong then it passes through as a output. Otherwise if it is signal, the amplifier will be magnifies the weak signals and again it fed back through the feedback network. So like that the continuously the process ongoing when it gives the sustained oscillations. Okay, that oscillations will be maintained if the loop gain is means the magnitude of A into beta is equals to 1. So here the second condition will be satisfied. After satisfied these two conditions, the phase shift oscillator is acts as an oscillator and gives the sine output as the sine waveforms. Then the frequency of that oscillations are totally depends upon the RC values, and the frequency is given as the F naught is equals to the 1 over 2 pi RC root 6. So after modifying this one, you will get F naught is equals to 0.065 divided by RC. So the frequency of the oscillation is totally depends upon the feedback network, or you can call it as simply R and C. Okay, so this is the formula for finding the phase shift oscillator of the frequency. Then the feedback fraction of RC network is means the feedback fraction means that is beta is equals to 1 divided by 29. So here also the beta will be varies by the different varies by oscillator to oscillator. So here in the phase shift oscillator the beta value becomes the 1 by 29. So when beta becomes 1 by 29, then we can write as the gain of the amplifier means the open loop gain can be written as it is equals to, or it must be greater than the 29, or it can also written as the 1 by beta. Okay, right. In order to satisfy the Barkhausen criteria, the magnitude of A into beta is equals to 1. The open loop gain AV of the amplifier stage must be the greater the 29, or it can or 1 over beta. So this is about the phase shift oscillator. Okay, And the advantage of the phase shift oscillator are it does not require transformer or inductors. So in the we know that we discussed in the circuit diagram, we did not see the transformer inductors, so it does not require for this circuit. So it produces the low very low frequency. Because why? Because here it produces low frequency because here we are using the R and a C. So when the combination of the resistor and the capacitor, it only produces the low frequency, or you can call it as audio frequency. The third one is it provides good frequency stability. Means the oscillations which are comes as output of the circuit, which have the frequency, that will be very stability. And the fourth one is the output is the pure sine wave, because we are in the RC phase shift, it gives the sinusoidal waveforms. These are the advantages. And the disadvantage of phase shift oscillator is the first one, it is not suitable for variable frequency, because it gives only the oscillation by the desired frequency or the constant frequency. So that's why it does not suitable for the variable frequencies. And the second one is the circuit gives the small output. So here the output of the oscillator will be very small, because it is continuous process. That's why the amplifier will be magnified, and the weak signals are again fed back. So that's why it gives the small output. And the third disadvantage is it is difficult for the circuit to start oscillations, as the feedback is very small. So the feedback network, means the three RC sections are very small in the circuit. So that's why the oscillations the circuit to start oscillations, the circuit will gives the small output. And it is difficult to start oscillations. Why? Because the feedback network will be very small. So these are the advantage and disadvantage of the RC phase shift oscillator. So this is the example for RC oscillator. So next, another example of the RC oscillator is called is another one, that is Wien bridge oscillator. So this also contains the RC sections of the oscillator, RC section combination of R and C. So it is a Wien bridge oscillator is a standard oscillator for low to moderate frequencies in the range 5 Hz to 1 megahertz. So here what is mean by low to moderate frequencies means it is a avoiding the behavior of as a high frequency. Means it is consumed as act as an the low frequencies. So in the range only the 5 to 1 megahertz. So that's why it is called as it is a standard oscillator for low to moderate frequencies in the range 5 to 1 megahertz. So means it only behaves as a waveforms in the range of 5 to 1 megahertz. So that's why it is called as low to moderate frequencies. Okay. And the Wien bridge oscillator circuit uses the either bipolar transistor or FET. So here in the Wien bridge oscillator, it is used bipolar, means the two transistor, or we can connect the FET, field effective transistor. And it is also consist the RC sections, but it consists RC coupled amplifier. Okay. And it also the two stage of RC coupled amplifier. So this two stage is provides the phase shift of 360, because the one stage is provide 180 degree and another one is provide the another 180 degree. So then the total phase shift becomes 360 degree or 0 degree. Hence therefore here no need to connect another the feedback network. So there is no phase shift network. It can also called as the phase shift network or feedback network is needed, because it consists the two stage of RC coupled amplifier. Then the circuit components R1 C1. So let us discuss by the diagram. Here this is the diagram of the circuit diagram of Wien bridge oscillator. So in the left side, so this one, this left side oscillator is called left side network is called Wien bridge. So this is the Wien bridge oscillator, uh, and here Q1 Q2 are the two transistor, means the bipolar transistor that are connected to the positive VCC. And here the Wien bridge acts as an near the feedback network, but it is not a feedback network, because the already the 180 phase the 360 phase shift is provided by these two Q1 and Q2, so no need to connect another phase shift. So here in the circuit, this acts as an feedback network, that is called Wien bridge. So Wien bridge is consist the C1 R1, C2 R2, R3 and R4. Here C1 R1 is called as a lead circuit, C2 R2 as called as lag circuit. So C1 R1 is connected as series, called a lead circuit, and C2 are connected as the parallel to each other, then that is called as lag circuit. So here after that R3 and this lead and lag provides a positive feedback to the network, and R3 R4 provides a negative feedback to the circuit. So here lead means the the high pass filter and low pass filter. So this the series combination of C1 and R1 is called as means it acts as an high pass filter, means it only passes the high frequency to the cutoff frequency. Okay, and this parallel combination of R2 and C2 are lag circuit, and it acts as a low pass filter. So it only allows the low frequency of the low frequencies which above the cutoff, below the cutoff. So then R3 and R4 are provides a negative feedback, and this lead and lag circuit are provides a positive feedback. Okay, so and these are the two transistor which is Q1 and Q2. Okay, right. So this is the explanation of the diagram. And next, working. So here the positive VCC, here the when power is supplied to the network, the signals are weak, random oscillations appears at the base of the first stage Q1. Okay, right. So after applying power, switching on the power supply, the positive VCC that will gives the input base of the signals are gives to the base of the Q1, and is amplifying at the stage 1 Q2, and this is gives the output. That output is goes to the base of the Q2 as a input, means the output of the Q1 are signals, those signals are becomes input to the second stage of the transistor, that is Q2. So after amplifying the Q2, here the uh, uh, signals are changes the phase by twice. Okay, so here the Q1 is only once the it phases the phase will be changed once, but at Q2 the signals are changes the phases by twice. Okay, after that the amplifying the signals at Q2, the Q2 gives as output. That output is again goes to the feedback, means the again it goes to the Wien bridge circuit through C3. Okay, right. So here, then after further amplification takes place by Q2, the phase inverted twice at the collector of the Q2. Okay, then the part of the output at Q2 is fed back to the Wien bridge circuit, and further amplification is carried out till sustained oscillations are provided and are called as sine waveforms. So here also this is the continuous process as like in the phase shift. So it for amplifies is carried out till sustained oscillations are provided. Then those oscillations, the frequency of the oscillations of Wien bridge oscillator is given by the f naught is equals to 1 divided by the 2 pi root of r1 c1 r2 c2. Then if r1 is equals to r2 is equals to r and c1 is equals to c2 is equals to c, then the frequency of the oscillation becomes, that is f naught is equals to 1 divided by 2 pi into root of rc. Okay, and this is also the feedback the frequency of the oscillation is also the it is also depends upon r and c. The feedback fraction in the feedback fraction of the RC network is beta is equals to 1 divided by 3. Okay, the beta value will be 1 by 3 for Wien bridge oscillator. In order to satisfy the Barkhausen criterion, the magnitude of the open loop gain and the feedback fraction is equals to the 1. Then it is must be means the open loop gain A will be must be greater than 3 or it can be 1 over beta. So this is about the Wien bridge oscillator, and the sum of advantages and disadvantages are there. The first advantage is it gives the constant output and good frequency stability. So it gives the constant outputs and it is also the frequency stability. The operation of circuit quite easy, so the operation will be easy. The frequency of the oscillation can be varied, means the oscillations will be varied by the continuous in the continuous process the frequency will be varied. The output has a very good sine wave. This also gives the very good sine wave as like phase shift oscillator. Since two transistors are used, the gain is becomes very high. The two disadvantages are there. The one is the components are many in number. So you know the in the circuit diagram, so there are many components in the circuit, so but the working is very easy, but the circuit diagram is very difficult or to explain or to draw. So the means the components are many in numbers. So the other disadvantage, it is not suitable for very high frequency, so it only uses the low frequency or it desired frequency. It does not use it for the very high frequency. So this is the about the two examples of RC oscillator. One is the phase shift oscillator and another one is Wien bridge oscillator. Okay, in the next class we will discuss about the combination of L and C oscillators. Okay, so in the we will discuss about in the next lecture. So this is all about the today's class. uh, Thank you so much.